To continue, now we're going to talk about an integer wrapper class for the primitive int type. Say I have an int I is 42, and I do system out print line of I. This should not surprise anyone that it compiles and it runs, and we get 42. Okay. Now, I is called a primitive type, or actually, I'm sorry, int is called a primitive type. Int, bool, float, double, those are all primitives. They're not objects. But Java is chiefly an object-oriented programming language. And so these primitives are kind of weird in that regard. So for instance, there's a method called toString, and every single object implements it. So you should be able to take anything in Java and call toString on it. But if I try to do this on a primitive, it says that int cannot be dereferenced, which is to say you cannot call methods on ints, which is irritating because it would be really nice if we could treat ints in the same way that we treat all other objects in Java. That is to say, to be able to call methods like toString on it. There are times, such as with array lists, that we're going to use in a moment, which is in fact why we're talking about this. There are times when you must use objects. You cannot have an array list of primitives. So we can't have an array list of ints. So what do? Well, Java has this thing called wrapper classes. And for every primitive type, there is a wrapper class that wraps that type and creates an object. So now when I convert the int in lowercase I int into uppercase I integer, I is no longer an int. It's an integer. It's an instance of the integer class. And so sure enough, I can use toString now. It compiles and it runs. So integers act like ints, although it's a little complicated what's going on here because 42 is not an integer, it's an int. Java does a little bit of magic to convert ints into integers and integers back into ints for you. When you do it this way, if I have int, say j is 42, I is j, to make it a little more explicit, this is clearly an int, this is clearly an integer. Converting an int into an integer is called auto-boxing. Going the other way around, j is I plus 1. Converting the integer back into an int is auto-unboxing. Interestingly, the unboxing here is not occurring when we assign into j. It's occurring when we add 1, because addition is not an integer thing, it's an int thing. So I can print this plus, comma, plus j, and when this will compile, and when we run it, we'll get 42, 43. But there's a lot going on here. Now, mostly you don't have to understand what's going on with integers and ints, and just you can think that you can use them somewhat interchangeably. Unfortunately, this is not actually always the case. And for that, I'm going to show you this example here. Come back here, we'll paste this in. Okay, and now let's go ahead and call this integer problem. So here's some code. I have an int I and an int j. Okay, and I is just going to go up to some large number, and we'll set j equal to I plus 0, which is to say we're just setting j equal to I. And if they're different, we break out of the loop. Of course, they'll never be different because j equals I. So when we get out, we would expect that I is 1, 2, 3, 4, 5, the first value beyond the loop, and j is 1, 2, 3, 4, 4, the last value inside the loop. We compile. J might not have been initialized. We'll just go ahead and do that. And we compile, and we run, and sure enough, exactly as we expected. Sure, so ints work as you'd hope. What if I made these integers? What's going to happen? Now only 128, 128, which is mystifying. But instead of adding 0, I'll go ahead and just do j equals I, which should be the same as I plus 0, and this time we're back to where we started. So it's mystifying. I'll clarify what's going on here, but I don't think it's going to clarify everything. And here it is. If I have an integer, say I1, which is say 42, and I have an integer I2, which is also 42. Let's do capital I, and I print out if I1 is equal to I2. Unsurprisingly, these are equal. There you go. But if instead of 42, I do 128, it turns out that these are not equal. And this, I think, is an extremely unfortunate decision made by the folks who made Java. This doesn't seem at all intuitive what's going on here. So let's discuss what's going on here. Integers are objects, and Java automatically shares a single instance of every integer from negative 128 to positive 127, because that's the range that can fit into 8 bits. So if you're outside that range, each time you create an integer outside that range, and 128 is outside that range, Java creates a new integer object. Now double equals among ints, not integer, ints does exactly what you think it should do. But among integers, double equals is not testing if they equal the same int value. It's testing if they're the exact same integer object. And in this case, this creates one integer object. This creates another integer object. They're different integer objects, so they are not double equal to each other, which is, to my thinking, tremendously unfortunate. Now, if you cast these into ints, then this test will work exactly as you would hope it would. True. So there's a lesson here. The lesson is you're going to have to use capital I integers at times, such as for array lists. You want to, as much as possible, do everything you can with ints, not integers, because ints will work the way you think ints are supposed to work, and integers will not. As an aside, why did this fail on I plus 0 but succeed on just I? Well, when we did I plus 0, this had to create a new integer instance. Interestingly, if you just do j equals I, it'll actually share the one and only instance. So that should be enough for some of you to understand why this works but this fails. For the rest of you, don't worry about it. Simply understand that ints work the way you expect ints to work, and integers not so much. That's kind of all you need to know for now. Next, we're going to move on to array lists.